with that, let's get started. My challenge today is to move you forward from the thinking of one isolated AI tool, which, by the way, Kai, incredible, rock the stage with all the features, thinking about the 10 tools from yesterday on Artist, right? All these things have their own superpowers in isolation, but thinking about them is an integrated ecosystem. And if my picture tells a story, it's the idea that that chain reaction is what we're going for. Think about this as compounding interest. If I have the gains of one chat, one assistant, one automation here, what happens when I combine them? The hypothesis that we have and the aspiration that we have as we have this ecosystem, the compounding effect explodes. In other words, my 2000, hours gain on a task can basically spill over with the 2% efficiency gain. And that combination of hours and efficiency could basically start telling this picture of the integrated ecosystem. Okay. Now, think about this through the lens of 4 angles. The benefits of multi-agents, is this idea that we need to have specializations. That means a task of always doing something. And then I can start bringing into a collaboration environment where AI agents start basically, in a way, sharing their capacities. This is how that compounding effect unpacks. Why? Because I don't know about you, but sometimes I have to do code switching and I go from dad to worker. Within worker, I'm the boss, the mentor, the manager, the student, and all that code switching sometimes allows me to have this cognitive load and going very strategic or very tactical. Oh my gosh, that is really, really, really exciting and difficult. Number 2, when you think about the cognitive load, I learned this early on in my career that what if I can gain 2 hours or 3 hours or 10 hours a week? And how do I redeploy that gain of time? And it was really interesting that sometimes we have these repetitive tasks that take us from the special sauce of the humanity, which is the high touch intervention, which is the counseling thing, the things that me, JC, or you, the leader, can only do. And that's really one of the exciting benefits of this multi-agent participation, right? And last but not least, it's this idea that scalability is really what the play here. The institutions that we represent, the partners that we have, they are resource scarce. There is this number of hours, number of employees, number of classrooms, number of programs, faculty members, and so on and so forth that allows us to accomplish X, Y, Z. And more students are coming in, more applications are coming in, their expectations change, and the resources are limited. So scalability across institutions is really the play that we have here, and amplifying that through the lens of improved workloads, and multi-agent approaches and systems is kind of the play here. Yesterday in our keynote, we presented this graphic as a visual. So I'd like to remind you what this looks like. This visual, in this case, coming from Google co-scientists, is one of the architects or the scaffolding that we are going to be using. You start thinking about how multi-agent systems will come and collaborate. And what I want you to think about is the granularity of how it takes place. So left-hand side is a scientist. Think about it as a faculty member that you spend time with. She is a tenure track faculty member, and her job usually consists in looking at opportunities in terms of research goals and elaborating research proposals in terms of papers, in terms of seminars, in terms of experiments that allows it basically to answer the question in the research goal. The research goal usually has some type of hypothesis, some type of proof that we need to do. And it could be inductive or deductive learning, all those type of things. And then an hour later, a month later, a year later, or if you follow my presentation yesterday, 5 years later, you'll have an answer to that question. On the right-hand side, what you start seeing is now how we start thinking through multi-agent approaches. And the punchline here is look at the granularity, everybody, of the agents. There's generation agents, there's reflection agents, evolution agents, proximity agents, and meta agents. And look at the aspect of the recursive, this kind of loop that runs this process over and over and over. Why does that mean? I need to generate an agent that specializes only in literature exploration. That agent at the top tells our scientists all the information, all the knowledge, all the paper, all the documentation on the research goals that she's exploring. Our second agent, now in this case, does a full web research, starts simulating and does deep verification. Think about it as a counter of that generation agent of literature. The third agent does the inspirations, simplifies the research, and starts doing an extension to the research. Our proximity agent or meta agents start basically formulating how this can work in terms of the research goals and the hypothesis and the experimentation that you need. And then you know what happens? You run it over, and over again. But those loops could take seconds as opposed to years, months, or days. So I'll leave you with this visual because to really understand multi-agent collaboration, we need to have a framework. And what I like to do in the remaining time is remind you what faculty are all about and how we can start using that framework to have a conversation on admissions, student success, retention, and all the activities that we do on student engagement. If you did not attend yesterday's session, a quick primer on TACO is this idea that there is types of assistant or agents that come our way. Some of them will be specialized on just doing a task. Some of them are more complex and they have interactive support because they are automators. The third category of these multi-agents will be collaborators. They function more like teammates and they push things through workflows. And last but not least, a type of agent that coordinates is our orchestrator. So 4 agents emerge, and the play that we want to do here is how do I put them together to accomplish an orchestration, a collaboration, an automation on a task? Okay. So let's see this in action and let's start thinking about how do I start building towards a roadmap that allows me to do this at home as student affairs, retention, financial aid, or whatever representation you have with us today. To inspire the conversation, I launched a deep agent, in this case, using deep research for perplexity to do a research study on what are the gains, the compounding effect that I just mentioned, found across all the experimentation that it finds on the web that justifies the need for taskers, automators, collaborators, orchestrators. And remember, my premise here is that combined, there's cumulative effect and gains throughout this. Now, what this research suggests is that across all the taskers that evaluated, it's seeing efficiency gains between 40 and 60%. I believe in the research, there are about 22 examples that picked and choose, all of them centered around educational technology, not exclusive to higher education, sometimes going to K-12. But you start seeing that now automators are showcasing gains of 15 to 80%, collaborators 30 to 45, and orchestrators with that range going all the way to 95. Punchline in efficiency, it seems that collaborators have the less efficiency because their job is to, by design, bring in the human in the loop factor. So by us inserting us there, we want to slow down this process because it's about validation. Therefore, the efficiency gains are a little bit smaller. What I really love is the fact that orchestrators showcase the largest range in terms of efficiency gains. All of a sudden, think about the process that you're doing, trying to get an efficiency gain of almost 95%. It's really, really unprecedented and exciting. Our third column speaks about the error reduction. Error reduction thinks about we're doing this with a probably human proposition. It's been done in this way. The moment we start doing it through the agent, taskers, about 22 of them, saw an error reduction of 70 to 95%, 60 to 85% automators, and you can basically start seeing the numbers. What does that mean? Is that some of the fears, some of the anxiety, some of the nuance of launching agents really starts going against the status quo, against the human intervention and how error reduction can be done human driven. I'm going to give you a really classical example that we use in classrooms when we teach AI or data science. But think about a Tesla being in autonomous driving through the streets and creating a fatality. One of the saddest things that we can see is someone dying because of that car accident. Technology can do that. But when you look at its counter fact, us humans driving and creating accidents, the rates are totally out of control. What am I saying? We humans create more accidents, more errors than computers and automation we do in Tesla driving. So this is the example that also validates that through the application of these agents, we start to see a lot of error reduction. Is really exciting to see how it gets deployed. The last thing that I'd like to give you in this information, as it explore and summarize 22 or so projects across the world, I asked it to give me a summary of how hard it is to implement it, right? And I think this says a lot about how much maturity we have, and some of the information that we saw yesterday in the AI maturity is probably pegged to this. At the same time, how much internal collaboration with teams is needed. But at the end of the day, what we can see is that taskers are easier to implement. And as we move down this um, table, the complexity emerges to the point that it says that orchestrators are critical, AKA more difficult to implement. So what I'd like to do next is now let's start going one by one and start giving you examples of how we do this in our domain. From the research that we did, I'm trying to basically capture 2 or 3 examples that give you the color that I'm talking about, right? And what I want to build this example and this narrative for us to is, how do I have a blueprint that allows me to do multi-agent implementation at home? So the first example that I've extrapolated from the 22, it's a financial aid document processor. Think about a financial aid form, FAFSA, right? That probably has number of fields from your family representing, where you come from, the financial aspects. You guys know the amount of error that generates, that if introduced, because some of them could be manually done, you're translating from different systems or forms, is significant. Therefore, we need to deploy these verification systems. What we saw in this Georgia State study that comes from a DOA grant, about $7 million, I believe that's what faculty members realized, is that by applying OCR and NLP, optical character recognition and natural language processing pipelines, in other words, a form, it's digitized and is read, we went from validation from 14 days to 22 minutes. That is a task. It only reads PDFs, digitizes, and understands if this financial aid is ready for evaluation. That's the role of the tasker, and that's the efficiency gains that it brings. And the examples that we saw, these are really interesting collaboration and automation example. It comes from Northwest, and it's an IT audit that comes from last year. And this automation is very interesting. What is happening is you're scanning about 500 and plus syllabi across your content management system. And then you're trying to understand, are these compliant with WCAG standards? A really important aspect of the work that we do when you need to basically keep up with grants and keep up with compliance and multiple things like that. So just think about looking at syllabi and manually inspecting, are they in compliance with our WCAG standards. So by creating this collaboration tool in automation, now you're able to bring that task. It converts 92% of the flag materials to accessible formats within 4 hours. And then it then pushes back, that's the automation aspect, to the LMS, giving 99.8% of synchronization accuracy. In other words, telling the faculty member, this is not in compliance, please go ahead and do the intervention. And the fact that this happened within 4 hours is really has been a game changer for this institution. Our third example, it's going to be on collaboration, a type of agent that is trying to bring in the human in the loop and create these interventions that use part AI, part human. The example that we see here is a collaboration that uses the data from an LMS and pairs it with wellness centers. Why? Because think about from student success, we want to generate risk interventions, and the fact that this sometimes could be observable in the student behavior and they come in a little too late, it's one of the things that we're trying to build across our campuses. So the fact that we can do this and within 48 hours, it generates an updated score so that academic probation, in this case, showcasing 33% improvements in cases, it's really, really, really exciting. This study was conducted also at the Georgia system, and it has some references here on institutional research. So I'm happy to share this as you can kind of dig in their information, but it's really, really exciting to see how this collaborator agent also is taking place. Obviously, our last agent is the orchestrator. We go from tasks, we go from automators, we have collaborators, and now the orchestrator. This is where it all gets put together. And I really love this report that comes from DOE, in which it looked at a school that grabbed 12 specialized agents. Really, it was 12 different models, if you think about it, from the world that I come in predictive modeling, and many of you have predictive models that do likeliness to apply, to churn, to basically predict actions in the classroom. What this orchestrator is doing is grabbing these 12 of them and trying to generate a forecast that will trigger different actions. In this case, what it's looking is predictive analytics, financial aid automation, and program demand through these agents. It coordinates between the 12 different agents and models to generate a 15% increase in real-time financial aid adjustments. Very, very, very exciting. And by the way, the accuracy of this compounded effect, very, very, very exciting. So these 4 examples that come from this research conducted by Perplexity ground the idea that there is a way for us to do multiple stages of agents, aka multi-agent orchestration. And my job now is to put it together into a roadmap of how do I bring this home. I know you tell me there's a task here. The job is to get these AIs to do tasks. You tell me also that if I have an automation, I'm going to be starting to move forward in multi-agent collaboration. But I need collaboration and I also need orchestration. So let's take one at a time to fully understand how this can be deployed at home. Our objective here is to give you a blueprint of how you can be doing it in your domains: student success, academic affairs, enrollment management, registrar's office, alumni affairs. You get it. First, to think about the tasker, what I'd like you to think is about 3 high impact workflows. I need to matriculate my students. That's a workflow. It could look like admissions sends a flag to the registrar's office. It could be that the student is sent to the admissions office, a little bit more manual, but that's basically matriculation. Multiple workflows can be orchestrated, and what we're trying to do is create an AI automation against that specific workflow. The part that I'd like to leave you with is we need to give you the accountability that this task is actually working. So creating an additional monitoring dashboard, some type of audit trail that these tasks are being completed as per your standards, it's fundamental. Why? Because on the automation angle, you want to bring this task or 3 tasks that you've built and connect it against 3 systems. Look at your SIS, look at your LMS or your CRM. And that is basically the middle layer. They're going to try to come and say, all right, now that I have the task, how can I do it real time? A API feed, a export that moves automatically via a schedule, right? You needed to do this type of task and put it in a feedback loop that looks at data and runs it and is automating in real time. At this point, this is where in this roadmap, I believe the type of complexity gets really interesting, because to launch collaboration, no pun intended, you need to collaborate with other sides of the house. In other words, this is where I recommend you bring 2, 3, or a small team of experts technical folk from your organization that can start looking at this and validating with you the human in the loop components. So think about, do you have research assistants? Do you have institutional research folk, data scientists, whatever type of legal configuration you have in your teams, in your organizations, bring that type of folk and start doing the human in the loop collaboration. Hey, we're doing a task around matriculation. Now I'm getting CRM data. Yes, John was supposed to matriculate. That makes sense. I'm going to prove it. I look at 10 other exports. I look at 10 decisions, and automation and validation will come in. Last but not least is the orchestrating. This is where I'm recommending schools today to establish this AI governance council. It's a cross-departmental, cross-team deployment of AI. Look, as AI champions, whatever representation of the school that you have, admissions or academic affairs, library systems, to do orchestration, we start looking into how our teams collaborate with other teams. And some of us have experienced incredible dynamics with other teams. Some of us have seen that our teams are siloed. The most effective way of seeing this, it's when the organization and the school puts together an AI governance council across the department team, a task force that represents 2 or 3 or 4 different teams. And this is basically where you want to bring this multi-agent approach. Orchestration will be very difficult to do, and it's more of a technical endeavor. We can talk about how you deploy it, but from the human angle, from I guess where you stand in different organizations, I highly recommend you think of it as a task force. And your target would be, number one, your knowledge base, how you start looking into the information sources that feed these taskers, that feed the automation and the potential collaboration, and then creating the continuous improvement programs, the training and the experimentation with that. All right, friends. So to wrap it up and give us 2 or 3 minutes to go into our last session for the day, this is an example that brings it all together in the context of student success. And you can be doing this for admissions, races, you name it. I'm going to give you a very simple way how to start thinking about it. So first, I'm going to create a agent called the Great Watchdog. It's a tasker. It constantly scans the student performance. Why? Because its goal is to identify in grade if you missed a class or if your grade is below an average. There could be a personality, and you start thinking about how they behave. And across these different agents, you're always going to see the role, the goal, and the personality. We saw in other sessions that you can start building these in memories, in advanced ChatGPT functions, and multiple tools like that. After that, we need the automator. This is the one that will create the alert system and automatically sends the message and the reminders for the Great Watchdog flags. Cumulative. Then we start looking at the advisor liaison. It collaborates by creating flags with students and real advisors, tutors, professors, and it starts consolidating schedules and resources. So that's where you start getting that human angle. And finally, the orchestrator is the one that would take place, the idea that an agent can saturate the experience of a student, can start sending all this information, or in other ways, can start basically sending misinformation that the student is really not at risk. This is a really simple way to start looking at multi-agent orchestration through the lens of tackle. Look at the role, goal, and personality. My friends, we are at time, and let me just do a quick check. Thank you, Davin. We should, next time we're in a conference, let me know. Any questions or comments? Our chat room and questions seem to be great. So with that, let's take this conversation to the end. We, for the past 2 days, and I would say 7.5 hours, have been having a conversation that it's very one-dimensional and rich. One-dimensional in that us, the administrator, the leaders, the humans behind the service delivery institutions are trying to bring AI to service our students. So One fascinating session, the last one for the day, is what are they thinking about this and how they're preparing, how they're expecting this AI deployment to help their lives, improve their on-campus experience, but more importantly, augment these realities of students in classroom, outside classroom, and their overall campus experience. So I will see you in our next chat where we get to hear from our students. Thank you, everybody, and we'll see you soon.